In this video, we're going to learn how to determine the present value of a lump sum of money. So in a previous lesson, we learned how to calculate the future value of a lump sum of money, but now let's say you know the future value, which is A here, and you want to find the present value. Well, all you need to do is solve for P. So we need to divide each side for the left equation when you're compounding n times per year by 1 plus r over n to the nt. So we'll have P is equal to A over 1 plus r over n to the nt. And when you do this, you can move that expression to the numerator by making the exponents negative. So the formula for compounding n times per year to find the present value would be A times the future value, 1 plus r over n to the negative nt power. So very similar, just with that negative exponent instead. And then for my compounded continuously, I would do the same path to solve for P by dividing by e to the RT. And we can move that e to the RT to the numerator by making that power negative. So the formula for compounding continuously, for an account compounded continuously to find the present value, is A times e to the negative RT. So really quick how this works is if we want to find the principal needed to get an amount, that is the present value. So the amounts given are the future value that we want to end up with. We want to find out where we should start to get there. So if I want to get $600 after 2 years at 4% compounded quarterly, I'm going to use this left formula. The present amount value I do not know, but the future value I want is $600. And I'll multiply that by 1 plus the rate, 0.04, over the number of compoundings, which since I'm doing it quarterly, that is 4 times, all raised to the 4, or the negative 4 times time power. And time here is 2 years, so t will be 2. So the present value will be equal to 600 times 1 plus 0.01 to the negative 8 power. So 600 times 1.01 to the negative 8, which when I plug it in will give me, so 1.01 to the negative 8, $554 and 9 cents. So you need to start there in order to end up at 600. So if I wanted to get $1,000 after 2.5 years at 6% compounded daily, I'm going to use that same formula where my present value will be my future value of 1,000 times 1 plus my rate, 0.06, over 365 years. 365 days, because if it's daily, that's how many compoundings you're going to have, raised to the negative 365 times 2.5 years, so 2.5 power. And that present value to get there is going to be less than 1,000, but by how much? So 1,000 times 1 plus 0.06 divided by 365 raised to the negative 365 times 2.5 power. So $860.72. So I need to start there to end up at $1,000 after 2.5 years. Now, where this can really come in handy is if you're given a zero coupon bond. That just means a non-interest bearing. Can be redeemed in 10 years for $1,000. That non-interest bearing means it's going to stay worth $1,000 after 10 years. How much should you be willing to pay for it now if you want a return of 8% compounded monthly or 7% compounded continuously? So let's say that 1,000 is the future value of that bond. And we want to determine what the present value should be to get this effect of 8% compounded monthly. So we would just use the same formula where our present value is what we're looking for. The future value of that bond will be $1,000 times 1 plus our rates, 0.08, divided by 12. Since compounding monthly means n would equal 12, to the negative 12 times 10 power, since it's over 10 years. In this case, we'll have 1,000 times 1 plus 0.08 divided by 12 raised to the negative 12 times 10 power. So we need to start with the value of that bond should be $450.52 to get this deal. So we should purchase it for that much, and then it will grow into $1,000 over that 10 years. Now, if we did it continuously, well, our present value will equal the future value, $1,000, times e to the negative rate, because we're going to use the second formula, rate, which is 0.07 this time, times 10 years power. So plugging that in, we'll have 1,000 times e to the negative 0.07 times 10 power. And we would need to purchase that bond for $496.59 if we want to get that outcome of $1,000 after 10 years following the 7% compounded continuously deal. And that is how you determine the present value of a lump sum of money.